Hey, these are notes 11.3 about arcs and central angles. So the vocabulary, a minor arc is going to be the smaller part of a circle when it's split into two parts. So like here's a circle, and going all the way around this circle is being split into two parts because there's the part from A to B, and there's a part from B going through D back to A. So the minor arc is going to be the smaller one, and the major arc is going to be the one that goes around the long way from point A to point B. The central angle is going to be the angle that is at the center of the circle. The measure of your minor arc will be the same as the measure of this angle, and the measure of the major arc will be the same as the angle that would be on the outside over here. So it's going to match its central angle. And then semicircle just means half a circle. So the way it works, if I'm asking you to name the minor arc and name the major arc, your minor arc is always going to have two letters, so like AB, and the symbol that goes on top is an arc. If you want to do the major arc, that's going to be the arc that goes the long way around, so it's going to go A through D to B. That means your major arc is always going to have three letters, and the letter in the middle is going to be the point where it goes through and keeps going. So if you call this major arc BDA, that's still okay, or ADB is also good. The measure of the minor arc is going to be the same as the central angles, the smaller central angle, so that would be 60 degrees. And for the major arc going the long way around, if this piece is 60 and a full circle is 360, subtract the 60 from it, and you'll find out what's left for the major arc. Number 2, your minor arc is going to be JM, and your major arc is going to go a long way around, so it'd be JLM. The minor arc is going to have the same measurement as this angle, and for the major arc, get the full circle and subtract 110 degrees, and you have 250 degrees left for the major arc. Third problem, the minor arc is going to be YZ. Don't forget that arc on top of it. Major arc is going to go the long way around, so YWZ. The minor arc is going to have the same as this central angle, 40 degrees, and the major arc, subtract from the full circle, and you have 320 degrees. The other thing that's in these notes is the arc addition postulate, very similar to the segment addition postulate we did from before. So if I'm looking at arc AB, for example, that matches the central angle of 40, so it's going to be 40 degrees. Number 5, BD, that matches the measurement of the central angle, which is 60, so there's 60 degrees. For DE, matches to the 120. AE would be whatever's left over after you get rid of all of these. So you get 360 minus 40 minus 60 minus 120, and find out what's left over. Once you subtract them, you get 140 degrees left over. That has to be angle ACE, and it's also the measure of arc AE. For AD, this is where the arc addition postulate's going to come in. AD would be 40 and 60 more. So if you get 40 and 60, you find out that it's 100 degrees from A to D. For EAD, That's everything except for that 120. So you can add 140, 40, and 60, or you can go 360 minus this piece we're not using. So 360 minus 120, we're at 240 degrees for EAD. For AED, that's these two pieces together. So it'd be the 140 and the 120. So it's 260 degrees. And then for EBA, starting at E, going through B before you hit A, that's everything except for the 140. So I'm going to subtract the 140 from everything, and I'm left with 220. Congruent circles means they're exactly the same size and same shape. So all circles are the same shape. The thing you're really looking for is, are they the same size? So if you have a radius of 7 here from X to Z, then if you add 3 and 4 and you get 7 also this way, that means that this large circle is going to be congruent to this large circle. Congruent arcs are going to be arcs that are exactly the same as well. They have to come from circles that are congruent, and they have to have the same measurement. So 85 degrees here for arc YZ would match with the 85 degrees here for arc DE, because they both came from circles that had a radius of 7. The arc length from Y to Z wouldn't measure in degrees, it'd be measured in feet, yards, inches, millimeters. They'd be measured by distance instead of being measured by angle or by degrees. So these examples down here, number 1, it says find the measure of the arcs and are the arcs congruent. If they come from the same circle, we just need to make sure the angles are the same. So if I look at BC, BC is 58 degrees. And if I look at EF, EF is also 58 degrees. Because these are exactly the same, then that means that yes, the arcs are congruent. So arc BC is congruent to arc EF. Next one, BC. BC is 58. And CD. This one we're going to have to find it like we did on the back side. So we're going to go 360 minus all the angles we already know. And you find out that you have 72 degrees left for angle CAD or for arc CD. Those are not the same, and because they're not the same, then that means the arc BC is not congruent to arc CD. Next one, arc CD, we already found out that was 72 degrees. And arc DE, we already see that that one is 72 degrees. They're the same, so that means that arc CD is congruent to arc DE. Number 4, this major arc BFE. BFE is actually a minor arc. So on number 4, this arc BFE is actually still a minor arc because it's still not more than 180 degrees. So BFE is the 158 together. And then CBF, that's 58 and 100 together. Because they're the same, arc BFE is congruent to arc CBF. The next section is talking about arc length, and it's a proportion. You're going to get two fractions, make them equal to each other, and once you get the pattern down, it becomes really quick. But at first, you have to remember where does everything go so that everything becomes really quick. Remember the way fractions work, the piece is on top, the total is on the bottom. So if you think about in degrees, a full circle, the total is always 360 degrees. That's why the denominator of one of your fractions has to be 360. Then if you think about that same circle, and you were talking about the distance going around it, that'd be the circumference, which would be 2 pi r, and your radius is 2. So if you put this in the calculator, that's going to be your other denominator. So the totals are always going to be on the bottom. On one side, the total in degrees. On the other side, the total in a distance. The part you care about is the piece of the distance around. So that's why your variable goes here on top of the distance going around. And that 120 degrees, it's in degrees. 360 was in degrees. Put that on top of the 360. Setting up the problem will remind you which two are going to multiply and which one's going to divide. You're always going to cross multiply, so 12.56 and the 120. And then whatever that gives you, the next step is always going to be dividing by the 360 because that's multiplied with the x. So divide by 360. And your final answer, remember we have to round to the nearest tenth or better, would be 4.2. For the next problem, you're going to set up the same thing. You know that every circle is 360 degrees. You need to find out what is your circumference around this circle using that radius of 4. So 2 times 3.14 times 4, we're at 25.12. That's the whole circle circumference. The angle is going to go on top of the angle, so degree on top of degree. And then you're looking for that arc length, which is the piece of the circumference. So you're going to get 25.12, you're going to cross multiply it times 180, and then you're going to divide by 360. And you get 12.56. And then for number 7, same setup. You're going to go 90 over 360. You're going to have to find your circumference with a radius of 6. You get 37.68. You're looking for the piece of the circumference. So you're going to multiply 37.68 times 90. And then don't forget at the end, divide by 360. You get 9.42.